Welcome to all. This class is not for engineering mechanics. This is a class, see written here. This class is for ongoing EATABS and SAFE course. See, EATABS and SAFE course is running right now. For them, information required regarding load transfer. And also for upcoming STAAD Pro course. STAAD Pro course will be upcoming starting on 15 September 2025. I will tell you why I am uploading in YouTube this class. See, load transfer. The principle, how from slab load is transferred to beam, I will thoroughly explain in this class. Everything covered. See, I written here. Both one-way slab and two-way slabs considered. Of course, we are considering only rectangular slabs. If it is not rectangular, in the respective course I will tell. Some corrections are there. 99% case will be always rectangular slab. Okay. Then, further, the purpose. See, in this course, EATABS and SAFE course, and also coming up STAAD Pro course, recording will be there. It will be sent for participants same day. But after some time, I will give usually long duration, maybe sometime even up to 1 year also, so that they can go through everything and understand. Then I have to delete it. It will be deleted because I do not require my own class for my reference. Once I delete, later, if they get doubt, they have to depend on what they have written. So, for that purpose, this portion I am uploading on YouTube, so that even after, see, this YouTube class will not be deleted, it will be permanent. Therefore, any day after the course is completed, maybe 3 years, 4 years later, suppose they get some doubt, they can refer to this class. And meanwhile, I will explain in such a way that it is useful for others also. That is not those who are not in this course and also not in this course. This course is still to start, another 2 more days only. Why? Because general information, useful. I have been telling all these days, my purpose is to give education. So, these courses is my professional course. People who want to join should register. But still, others, they can benefit from this one. So many people I have seen has got doubt, especially academic field, even practically also. Sometimes people get doubt how the load is transferred. So therefore, this is a permanent one now. It will be always there. What I wrote here right now is brief sketches. I will not explain much here because one by one, see, 1, 2, 3, 4, 5, 6, 7, 8. Total 8 examples are here. Once I briefly explain all these, one by one I will take in order. Before that, some principles I will tell. So now briefly I will tell. See, this type of arrow mark is for one-way slab. See, this also is for one-way slab. See, single arrow mark here. Here this way and this way. This type of arrow marks means the slab is projecting outside of an overhang. Somewhat like cantilever. See, here, overhanging this side. It can be that side or this side. Okay. Here, overhanging this side. See, this case is, suppose the beam is, see here, this is the beam. Lengthwise overhang. Other cases, see, beam is here, widthwise overhang. These are all plan. Remember, these are all plan. Look, see, perpendicular is the height. Okay, now, this type of, see, this symbol is usually used for overhanging side. Now, here, slab is supported on both the sides. See here, slab is supported on both sides. Red color, see, in all my example, red color is beams. Red color is supporting beams. The red color is supporting beams. So understand correctly. supporting beams. And I maintain one thing to avoid confusion. See, A, backside, A, B, C, D. Or, see, if I take a slab here, A, B, backside A, B, front side C, D. So that if you see front view, see, anywhere, see this beam. If you see front view, you can see AB beam and CD beam. If you go for side view, you can see AC beam and BD beam. This I maintained throughout for understanding. Now, see, here, this is a one-way slab. See, this is one-way slab only, one-way oriented. This is one-way supported by these two beams. Someone will ask, sir, beams are there here also. No. See here, something I wrote here. Ly by Lx is more than 2. This I will explain it later. Actually, people are knowing it. When the ratio of longer side, see here, 1 minute. See here, it is one-way slab. It cannot bend like this. Here, it cannot bend like this, no support. But here, it can bend like this and also bend like this. But predominantly, it will bend like this only. So, this is a one-way slab. See, this way. This is a one-way slab this way. This I will explain. So, what I want is, outlook I want first. See here, load is transferred to this beam. See here. When you put the load transfer here, if it is a lengthwise beam, you go for front view. See, when you see front view, you can see load perpendicular this way. If it is a widthwise beam, you can go for side view. So remember, this is plan. Load transfer is not plan. This is side view. Plan, front view. Plan, side views. Plan, front view. That way, see. These are front view. These are side views. Okay, now, one-way slab here, one-way slab here. Why, even though supports are here, still why one-way slab? It will come with later. See, outlook I am giving. So here, one-way, see, one more thing I want to tell. This class was already uploaded earlier, long back. Then, after uploading the class, I took the class for EATABS&SAFE because all these models are made in the software where we assign the load and get the load transferred to beams. In the class, we will get the load. Then we will check how much load transfer will come in the software. Of course, same answer will come. It already got verified. See, I took the class for them. EATAB, see, for this load transfer principle class for EATABS&SAFE batch already considered. They all told, sir, perfectly tallying. See, when the models are prepared, when you assign the load, how I explain in the class load will transfer, same way the result came in the software also. It will come in the EATABS&SAFE and also it will come in STAAD Pro. Later in the course, I will tell you that time. You go through that YouTube class. Then I will continue. Here see, modeling is by EATABS&SAFE. Here modeling is by STAAD Pro. Whether it is EATABS&SAFE or STAAD Pro, result will be same. Okay. Now, why I am uploading second time? That uploaded earlier is still there. If you click, it comes a private video. There is a reason. See, for simplicity, for complete all the 8 examples, see, at that time there were 6 examples. These 2 are not included. Now I decided to include this also, overhanging side. So all the examples there, I told at that time, slab load, that is dead load plus live load was 9 kilonewton per meter square, and beam, dead load, self weight of beam and weight of wall together, it was 13. So what you have to do is, the slab load of 9, see, it is this is 13 kilonewton per meter. The slab load which is in kilonewton per meter square, you have to transfer to the beam. For that, you have to multiply this 9 with some distance. I will tell you now. How to multiply, I will tell. When you multiply the slab load See, by which one? Some distance. What distance I will tell it later, because wait for some time. I will tell the principle also. You get the load transfer to beam in kilonewton per meter. To that one, you have to add this one. Everything was done, but the recording was done late night. When I was approaching early morning, I was about to finish. What happened there was, in the beginning I wrote complete race class, slab load is 9 kN per meter square. This 9 kN per meter square is to be transferred to beam. This is directly for the beam. See, this is to be transferred, this is direct. So, you multiply by 9. I correctly multiplied 9, I multiplied by some distances, got the answer. But halfway through, in one example, because see, recording early morning, suddenly by mistake, I took the slab load, not 9, I took 13. By mistake, I took 13. Then 13 I multiplied by some distance to get the load transfer to beam. It is wrong. Actually, remember, technically not wrong. I explained there when I did that question. I told, see, slab load is 13, I told, but it is 9. In the EATAB class, answer was not tallying. Then somebody commented there. In the live class, sir, in YouTube, for this question and one more question, sir, by mistake, instead of taking 9, you took 13. I checked, yes, correct. Therefore, in that class, I told them, okay, change it to 9. See, they are my students. They are attending my classes. So I changed it. But this class is in YouTube, it is permanent. Tomorrow, you don't know the people. What is the nature of people? Without knowing anything, they start commenting. Someone will comment, slab load is converted to transfer to beam. But see, two questions. He is, instead of transferring slab load to beam, he is transferring beam load to beam. I will tell if he is in front of me. See, it's a wrong reading. Instead of 9, instead of 13, instead of 9, by mistake, I took 13. It is not technical mistake, because I wrote 13 kilonewton per meter square only I wrote. I told at that time, see, slab load is 13. Interchanged. But still, since it is in the YouTube, it is permanent. I do not want this mistake. It hurt. See, I got hurt by that mistake. Mistake means, remember, not technical mistake. I told technical mistake I will not make. Reading problem, see here. So, then I told in the class, okay, I am going to upload once again. Some comment came, sir, no sir, we can change it, sir. Sir, we will change it to 9 and do it. I told them, okay, you can change it, no doubt. What about those who are not in the group? Here. They will tell comment, some comment may come tomorrow. This person, slab load to be transferred to beam, he is transferring beam load to beam only. See, if they observe correctly, they can make out it is a reading mistake. But still, I got little hurt by that mistake. So therefore, I decided to once again upload the class. Once again upload the class. So that I will be careful this time. Therefore, that is the reason I made it private. As soon as I upload here, I am deleting it. Before that, I will note down the values. And one more thing, I will take the same numerical. Because for the course EATABS&SAFE and EATABS&SAFE, already we consider dimension given in the class. Therefore, I have noted down somewhere there all dimensions. So that dimensions I noted down, I will upload. Now I will correct the mistake that by chance interchange. So I will change it and upload the class. Okay, now see. One-way slab, overhanging type. Load will come to this beam only. Load will come to this beam only. Here. Load will come to this beam, radial. Load will come to this beam, once again radial. Here. even though supported on all the four sides, it is a one-way slab like this. Why, I will tell you little later. Therefore, load is transferred to only A, B and CD. See here, A, B and CD. No load for these two beams. See, this I will write when I do next time. I will write there. No load transferred to A, B, A, C and BD. Here, this way, one-way slab. Why? Because ratio is more than 2. So load is transferred to AC and BD. No load transferred to ABC, vacant. These two are two-way slabs. See, even if it is two-way slab, predominant bending will be along shorter span. So that's why, see, shorter span I made dark, longer span. Here, see, load transfer is like this. See, for this beam, uniformly, for this beam and this beam, uniformly varying load with 0 at the ends and maximum at center. See here. And for these two beams, uniformly varying load, 0 at the ends, maximum after some distance, and then in the middle portion, constant intensity. See here. Here, reverse. See, for these two beams, see here, these two beams, uniformly varying load represented by a triangle with 0 at the ends and maximum at center. But for these two beams, again uniformly varying load represented by a trapezium, 0 here and reaches maximum here, reaches maximum, middle portion constant. This is only outlook. Remember, everything I am going to explain now. Therefore, first see, what I want is, when somebody opens this class in the YouTube, by looking, they can make out, oh, this is required for me. See, if I don't write anything, simply if I write title, load transfer, so many will not open it. You don't know people. When they see such sketches, suddenly they feel, oh, yes, this I want it. So, purpose is what? To see that more and more people will go through this one. So, when I teach, even though this is for the professional courses here, this one I want for everybody. But one thing, there is a limitation. I cannot explain beyond the limit. Because why? If I explain each and everything limit, then it becomes RCC class. Or I will stick to load transfer principle. Load transfer from slab to security. Both one-way slab and two-way slab considered, of course, right, rectangular slab. Now, make a note. What is load transfer? See, briefly, when you apply load on the slab, it is transferred to supporting beams. Except in case of flat slab, where slab is supported directly by column. That is not covered here. It will come in a flat slab class. So everywhere, load on the slab is transferred to beams. Load on the beam will be transferred to columns. Load on column will be transferred to footing or foundation, and load on foundation will be transferred to soil. In structural engineering, there is a wrong concept. If you ask somebody how you design a slab, how you design a beam, how you design a column, how you design a footing, etc., people will tell, design the slab to resist the load coming on that one, design the beam for the load coming on the beam, design the column for resisting the load. No, it is a wrong concept. No structural member is designed for resisting the load. See, loads are not resisted. If slab is resisting the load, why you want beams? No, it will receive the load and transfer it to supporting beams. So there is a term called supported member and supporting member. Load from supported member will be transferred to supporting member. So load is not resisted. Wherever in a building you apply the load, finally load will go to soil. But what happens? Therefore, using the word designed beam or slab or beam or column, etc., are designed to resist the load is a wrong concept. It is only transfer. Then what is design? I will tell briefly now. This all, see, in my course later, this all I will highlight. When I start strength of materials, I will give a marathon lecture on this marathon lecture on that section forces, axial force, shear force, bending moment, torsion, etc. It will be more clear for you. Wait for some time. But here I will tell you. See, slab receives the load spread here this way, transferred to beams this way. Beam receives the load some in between, but transferred to column. Column receives the load at the top and transferred to footing at the bottom. So in this way, when a structural member receives the load somewhere and transfers it to the supporting member somewhere, what happens is the most critical. So I should show something now. It's a very powerful term, but so many people, they don't give importance to that one. Okay, I don't have it here. Okay, leave it. Something I will take. What happens is, suppose a beam, then the cross section, see, the most important word is cross section. The cross section of the structural member, cross section of slab or cross section of beam or cross section of column, the cross section of the structural member is subjected to section forces. 4 section forces are there, namely axial force, compression tension. See, shearing force, this way or this way. Then next, bending moment. See, one hand I can't explain. See here, bending moment. And lastly, twisting moment. These are called section forces. This axial force or shearing force or bending moment or twisting moment, which will come for the cross section, so many people, they tell these are all internal. They are wrong. It is not internal. One class in the YouTube I am uploading, fitting reply for those who tell it is internal. 99% people tell they are internal. Once I upload that class in YouTube, they will realize the mistake. It will be an eye-opener class. See, I will write there. This is an eye-opener class. Eye-opener. I will tell, open your eyes. Understand. Don't go for wrong. Someone told that way. Don't believe. I will tell, believe me. Someone will tell, why sir? Why should I believe you? If you really think I know subject, you can believe me. And I cannot be wrong. Therefore, it will be, in the YouTube, I am uploading it as an eye-opener. That wrong concept of telling axial force, shear force, bending moment and twisting moment as internal is nonsense. It is external. Internally, it is resisted. Why? See how many examples I will give. I will give at least some 10-15 examples. Some of them practical. Money matter will also come. Some problem, medical problem will come. Some, what you call, earning will come. So many things. You take a loan, that also will come. Then at the end of the class, I will ask. See, I will stand this way and ask, now tell me, internal or external? They will tell external. Then, we thought it is internal. Everybody used to tell. I should not tell. If you open Google and search for SFBM, it will come there. They are the internal. Their only mistake. I don't want to comment on Google. I hope one fine day they will rectify it. I will even inform them also, if possible. Correct it. Don't give wrong information. Sorry, I will tell for them. Sorry. It is a fact. People are carried away by someone telling that way internal. No, they are external. Wait for some time. I will upload in the YouTube eye-opener class. So now these section forces, see, 1 minute. Look at the beam, bending moment, internal or external. Axial tension. axial compression. By looking only you can make out external. How you can tell foolishly internal? Internal is resistance. See, in RCC, bending moment is external. Internal is moment of resistance or internal resisting moment. Those people who tell bending moment is internal, do you know what they will tell in RCC? RCC they will tell, consider a beam cross section subjected to external BM M. Now due to that one, let MU or MB internal resisting moment developed. Then I will tell, then what you told? Oh, I don't know what. See, they will feel guilty also for that one. Therefore, this I open will explain. So now remember, these section forces, they cannot be transferred. They should be resisted. That's why when you design a slab or design a beam or design a column or anything, structural member, you design the cross section for resisting the section forces. That is called strength, and also provide such a cross section so that deformations are within the permissible limit. That is called serviceability. This all I will tell later. Okay, right now sufficient. I talk too much, but I want to talk this one. Hope all have gone through up to here. So now this is ready for our load transfer principle. I will start now. One by one I will start. Now, I will continue. I will try to explain maximum concept, but there is limitation. I cannot go into RCC and explain RCC part here. And most of the people, whether they are in the group or general public, some basic requirement is there. Okay, start. Note, in this class, for all 8 examples, 8 example is because 6 one-way slabs, example 1 to example 6, and 2 two-way slabs, example 7 and example 8. For all these 8 examples, what I am doing is, I will take something common, because if I keep on changing slab thickness, beam dimension and height of wall, every time you have to calculate. Why? One standard you will take. See, all the 8 examples, today's class up to end of the class, slab thickness is 150 mm. Remember, reinforced cement concrete slab, right there, RCC slab. And weight due to finishes, weight due to floor finishes is 1.25 kilonewton per meter square. See, slab load is always per unit area. So, and live load, LL, sufficient is 4 kilonewton per meter square given. This is given by me, this is given by me. And one more thing is there, make a note. During design of slabs, practically another weight is considered, usually called weight due to partition. Partition. That what is that weight? I explain in the RCC class. Usually they take around 1 kN per meter square. Okay, now 1 minute. That all I don't consider here. In the practical design, I will tell that one. Today it is not there. So if it is there, consider it. What is there? Consider it. Okay, now all beams today, see, everywhere beams are coming, red color beams are of cross section 200. See, all beams are of cross section 200 millimeter by 500 millimeter. And columns will come today. All columns are of cross section 200 millimeter by 300 millimeter. Now, all the beams today are required to support wall of thickness 200 millimeter above the beam. All the beams. The height of the wall is 2.75 meter. See, this I am not given in the previous uploaded part. Extra I am giving. And the wall it can be brick wall, it can be hollow block, it can be solid block, anything. We will take brick wall, anything. Anyway, here, for every material or brick wall material, there will be density, weight density. So in this class, you take weight density for the wall. See, I told wall of thickness 200 mm and height 2.75 meter, weight density 20 kilonewton per meter cube. Remember, for RCC we take 25 kilonewton per meter cube. For wall we will take 20 kilonewton per meter cube. If it is something else later, take something else. Suppose it is not 20, it is 18, take 18. It is suppose a solid block, say 22, take 22. Hollow block, say some 15, take 15. So it is given 20 kilonewton per meter cube. Now most important, see what I am writing is for today's entire class. See, calculation of slab load. See, our main, you should write all these things. Our main purpose is today transfer of load from slab to beam. But we will not stop there. When you consider the beam, see, all this you have to write. Load will come from the slab. Plus, extra load is there on the beam. One is weight of wall. Second extra weight is its own weight. That also we will consider. So today's class, finally when you sketch the beam, we will consider the final loading on the beam, which is due to load transferred from slab plus self weight of beam plus weight of wall above the beam. Okay, then now see, slab load. First calculate self weight of the slab. Make a note, those who want. Self weight of slab is always calculated per unit area. Means, see, weight equal to volume into density, weight density. 1 meter length, 1 meter width. Thickness is 0.15. So only thickness considered. So make a note if you want. See, make a note. Self weight of slab is always equal to, see, slab thickness in meter. You write here. Those who are not knowing all this, write here. Self weight of slab is always slab thickness in meter. See, 150 millimeter. So 0.15 meter into weight density of RCC is 25 kilonewton per meter cube. See here, this is in meter, that is in kilonewton per meter cube. You will get 3.75 kilonewton per meter square. 0.15 into 25. Yes, 3.75. Okay. Therefore, make a note, when you want to calculate self weight of the slab, multiply the slab thickness in meter with the weight density of reinforced cement concrete. In India, we take 325 kilonewton per meter cube. We will always get in kilonewton per meter square. And remember, self weight is a dead load. Make a note. Then, weight of floor finish. In the question only given 1.25. I had given 1.25 so that when I add these two, round number will come. That's all. 1.25 kilonewton per meter square. It is given in the question. See, this is given. This is given. Okay, now one very important. Therefore, total dead load is 3.75 self weight plus 1.25 finishes 5 kilonewton per meter square. Remember now, meter square. And in the question given, see, given in the question, live load is 4 kilonewton per meter square. Suppose residential building, they may take only 2, 2.5, etc. Sometimes commercial building not 4, much more than 4 also. It is given as 4. These are all RCC part. Now, very, very important. This class, we will be considering load combination of dead load plus live load. See, Dead load plus live load is popularly called service load or working load. Either service load or working load. And remember, so entire today's class, we will take service load or working load. Now, one doubt, see question mark, it's right here, question mark. What about a term called factored load? No, today we will not consider. If you want a factored load, you multiply this dead load and live load with a suitable factor of safety. Load factor is there as per IS code for a dead load and live load, 1.5 you have to take. See what is there, multiply, that is not a problem. But anyway, technically remember, when you design, you don't go for factored load. You always consider service load only. Once you get all the effect and load transferred, and finally, once you get axial force, shear force, bending moment or twisting moment, some disturbance, you will be getting corresponding to working load or service load. 1 minute, it's giving trouble. Hard time, see. This is not under my control. Some dog is barking there. Okay. Hope it will keep quiet. You will understand the seriousness. Okay. Therefore, practically you always consider service load only, not factored load. Load factor, what you do is, once you get axial force P, shear force V, bending moment M, twisting moment T, you convert it into PU, VU, MU and TU, factored axial force, factored shear force, factored BM and factored torsional moment. Anyway, you are understanding load transfer. Some load we will take service load. If you want to factor load, factor now. What is there? Consider factor load and transfer factor load. Our class is not for this load factor all. Our class is load transfer principle for 8 cases. Therefore, see, today's class, we will not bother about factored load, right? Or that I will be discussing in RCC class. Okay, now, therefore, most important, see, dead load plus live load for slab will be, see here, dead load plus live load for slab will be 5 dead load, 4 live load, 9 kN per meter square is the dead load plus live load for slab. Therefore, today's class, make a note here. Today's class, for all the 8 examples, I am going to consider combination of dead load and live load. Therefore, in all the 8 examples, wherever you get a term called slab load, you write 9 kN per meter square. I will not tell again and again now. Stop. Kn per meter square. Now, okay, make a note. Now, what happened last time was I took 9 only. See, for beam, it comes 13 kilonewton per meter. I remember it. Due to early morning recording, got fully tired. Everywhere I took 9. But some examples, by mistake, I took 13. People are there to comment. See, they should understand, it is not technical mistake, reading mistake. Students told in my class, sir, no problem, sir, we will change it, sir. Okay, I told them, you can change it, but this YouTube class is universal, everybody can see it. I cannot tomorrow face a comment like, he does not know, he is transferring beam load to beam load. What I will tell? Open the eyes, I was telling slab load. By mistake, instead of 9, I took 13. Today I will be careful. Okay. So remember now, full class today, when slab load comes 9, I will put somewhere here later. Okay, now one more important is there. See, this 9 kN per meter square, see, kN per meter square slab load, when you apply on the slab, it will be transferred to beam. How that transfer takes place, we will discuss today. Once that transfer takes place, see now, right here, next. See, very important now, see, once slab load, today's class DL plus LL of 9 kN per meter square on the slab. Okay. When the slab load is transferred to beam, right here, some dictation, we will get load on the beam. How it comes, I will tell you later. But for the beam, extra load is there. Again, dead load is there. Live load is not there. Dead load is, one is self weight of beam, other is weight of wall, right here. That also we will consider. Therefore, finally, when you write the loading on the beam, it will be, I will tell once again later, load transferred from slab plus dead load for the beam, dead load due to self weight of the beam and weight of wall. Okay, now, very important, I write here now. Self weight of the beam, remember. So calculate now only. Self weight of the beam. Self weight of the beam is taken as UDL, remember, UDL. See, slab load, you multiply slab thickness in meter with the weight density of 25 kN per meter cube. Slab thickness in meter, kilonewton per meter cube, it will come kilonewton per meter square. But for beam, we are taking 1 meter length. So volume equal to width into depth into length. Length we are not considering, 1 meter length. So self weight of beam is always equal to breadth of beam in meter into depth of beam in meter into weight density of concrete, weight density of RCC. See, now equal to, see, this will be in kilonewton per meter cube. So breadth is today 0.2. See here, all beams are 200 by 500. 0.2 into 0.5, this will give the cross-sectional area in meter square. Length is not considered because we want to per unit length. Multiply by 25. See here, 0.2 is in meter, 0.5 is in meter, 25 is in kilonewton per meter cube. You will get the answer 0.2 into 0.5 into 25. 2.5 kilonewton per meter, not meter square, kilonewton per meter. Okay. Same way, calculate weight of wall. Weight of wall also same as beam. See, when the wall is here, wall thickness in meter, not millimeter, wall thickness in meter into height of wall also in meter multiplied by weight density for the wall material, density for wall material, you write there, equal to wall thickness, I told once again 200. See, where is it? Wall of thickness, I written here, wall of thickness 200. So it is 0.2, it is in meter into height of wall is 2.75. That also in meter. Weight density for the wall, I told 20 into 20. This is in kilonewton per meter cube. Answer will come in 0.2 into 2.75 into 20. 11 kilonewton per 11 No. I want 10.5. 1 minute. Height is not 2.75. Sorry. In the question, you change the height to not 2.75. So change the question. 1 minute. Change the question. 10.5 divided by 0.2 divided by 2 points. 10.5 divided by 0.2 divided by 20 is 2.625. In the question, change it height 2.625 meter because I want the same answer as last time. So make a change, correction. See, correction. Make a note. In the go back and change it. Don't tell me later, sir, you wrote 2.75. I will tell, go through entire class. See, somebody will tell. First he gives 2.75, but when he calculate, he takes first he gives 2.75, but later when he calculates, he is taking 2.625. Does not know the subject. Okay. I will tell for them. If you want to understand from me, go through each and everything. Don't randomly go like an entertainment video. This is education class. This is not a video. So if you don't follow all what I tell, don't listen to my class. Don't attend my class. Leave it. You study your own way. I am very harsh in that matter. Some will tell arrogance. Okay, no problem. It is not arrogance. I am not an arrogant person or a person with what you can call it. There is no arrogance in me. But I got confidence. See, every time, sometime I will tell, this is not arrogance, this is confidence. So change it to 2.625. Change the question. So it will come. Why? Because in the EATAB class and SAFE class, I already took, I tell you how much, 0.2 into 2.625 into 20. 10.5. 10.5 kilonewton per meter. See, this will give weight of wall per meter length. Now, with these two data, you write last step now. I will remove this one now. Therefore, after, wait, this is red color I should write. I will not tell once again now. Therefore, okay, last I will write. Therefore, dead load for beam, that is self weight plus weight of wall equal to 2.5 self weight plus 10.5 weight of wall is 13 kilonewton per, not meter square, meter. Okay, 13 kilonewton per meter. Now I will do one thing. I will put a statement here in the corner. Lastly, summary I will put. All I explained now, one small summary I will write here so that it will be there for the entire class. Let me see up to where I can write, first of all. Or I will write and explain. That is much better. I will write and explain. So, now see, I wrote something here. This I am not removing today. It will be there for the entire class. What I wrote here, this is, see, therefore, 1 minute. Therefore, what I wrote here will be for the entire class today. It will be there. For all 8 examples, slab load, dead load plus live load, 9 kilonewton per meter square. See, meter square, which is to be transferred for 2 supporting beams, red color. Beams will be red color. Then for the beams, we have to consider dead load of 13 kN per meter, self weight plus weight of wall, and finally get design load for the beam, that is working load or service load, dead load plus live load. That is, you can make a note here, space is not there. That is, you write here. If you are serious, write here. Load transferred for the beam from slab plus dead load of 13 kN per meter for the beam. See, load transferred from slab to beam the load for the slab is in kilonewton per meter square. But when you transfer it to the beam, it will become kilonewton per meter. Then you add it, so whatever this slab load, after transferring, whatever intensity you get for the beam, you add 13 kilonewton per meter. That is dead load for the beam. Okay, this will be there. Now, very, very important. Slab load is in kilonewton per meter square. I am telling 10th time now. That is per unit area. But when we transfer it to beams, we get intensity of load for the beam. Remember, intensity of load for the beam is per unit length, not unit area. That is, when this kilonewton per meter square slab load is transferred to beam, you get for the beam kilonewton per meter, not meter square. This intensity may be intensity of UDL for the beam or intensity of UVL for the beam. Write something here. See, I am dictating something here. See, I will dictate something here. Sometimes slab load, when you transfer it to beam, it will become UDL. Then it will be in kilonewton per meter. Sometimes slab load, when you transfer it to beam, it will become uniformly varying load. Then the intensity of the uniformly varying load will be again in kilonewton per meter. You should know one thing. See, whether it is, see, make a note here. See, just roughly. UDL, you write what? You write kilonewton per meter. Even UVL also, whatever is the UVL, see, finally you write what? Kilonewton per meter only. So, irrespective of whether it is UDL or UVL, when you transfer the load to beam, the intensity will be in kilonewton per meter, not meter square for the beam. Anyway, see final summary little later. One final summary I am writing now. Okay, now, very, very important. See, I will tell you some rough sketch I will explain. See here. This is actually not required to tell. You should know it. You imagine a beam here. See. Imagine a beam. This is a beam. Imagine this is a beam. For that beam, imagine slab load will come from here. See. This length of beam you take L. L. Now, this distance from center you will take, see, actually from edge you take the slab is there here also, but here beam weight should be below the slab. That all practically not considered. People take up to center. Some see, it will slightly give higher load. Safer side, don't bother about those things. See, this distance is, I will tell, x naught. This is perpendicular to beam. Perpendicular to beam. So, write a note here. For the beam, slab load will come for a length of x naught. Full load will come here. See. Then, see here. You consider unit length of beam. See. Unit length of beam. See, slab load. I will tell slab load is in kilonewton per meter square. Meter square, or that is per unit area. Unit area, slab load. Now see, consider unit length of beam. Unit length of beam. That is 1 meter length. See, put one more sketch here. One more sketch for the beam. See. You take only 1 meter length of the beam. See. 1 meter. This is 1 meter unit length. Now, load will come from this much. See. Load on slab on this area will be transferred to beam per unit length of beam. Now see, therefore, see the intensity of therefore load on beam will be, see, this area is required. See, this is x naught equal to slab load in per unit area into area of slab, load of which will be transferred to beam. Space is not there. The area of the slab, load of which is transferred to beam. Like see, suppose imagine you want to buy a 30 feet by 40 feet site. Total cost is, see, imagine 1,200 rupees per square feet. Then the total cost is whatever is the cost per unit area into actual area, 30 into 40. Same way here. See, this is the load per, slab load is per unit area. So, equal to slab load per unit area multiply by x naught into x naught into 1. This will give you total load. See, this will give total load transferred to beam per unit length. Now skip that 1 meter. Therefore, see here now, load on beam becomes load on beam from slab equal to slab load in kilonewton per meter square into x naught, that is in meter. See, kilonewton per meter square into meter will give kilonewton, that will give you answer equal to in what? In kilonewton per meter. That is intensity of UDL. Because why? Uniform load, intensity of UDL equal to slab load into x naught. Whatever you get is in kilonewton per meter. Therefore, I will do one thing now, or see, simply here only you can make out. For 1 meter length of the beam, this much load will come. How much? Slab load per unit area into x naught into 1. Okay. Therefore, finally I will write here. Therefore, conclusion, intensity of UDL on beam due to load transfer from slab equal to slab load in kilonewton per meter square multiplied by perpendicular distance from beam up to where slab load is transferred to beam. This is for UDL. Okay. Now I will give a small example for UVL just to understand, actually not required. See. Imagine this is a beam. See here now. Second example. Imagine this is the beam. Okay. Now this length is L. Imagine slab load come from here. This much slab load. See. This slab load is transferred to beam. beam. See, this is x naught. Again, perpendicular distance. Now, tell the answer. Therefore, total load on beam for entire length of L equal to whatever is slab load multiplied by what? Multiplied by area of slab. Slab load, I will take W suffix S. W suffix S into area of slab is half into L into x naught. This is total load on the beam. Now, therefore, for the beam, see what happens now, see here. For the beam, let it be this way, load. This is load on the beam, see, this way. W per unit length, uniformly varying load. Now, if the length is L, total load equal to half into L into W for the beam. Why? When uniformly varying load is there, total load equal to area of the triangle. Now, equate these two. What you get? Ws into half into L into x naught equal to half into L into W for the beam. Half cancels. Then L cancels. See here. Therefore, W for the beam equal to W for slab into once again x naught. Same answer. Now I will conclude it by writing the final summary, and later I will not explain. See, those people who cannot go through each and everything I tell and make a note, randomly going somewhere in between, then telling this is not clear, that is not clear, let it not be not clear, leave my class, I will tell. Therefore, see, irrespective of, okay, I will use red color, because why? Next time not telling it. Red color I write here now, see, once for all. Therefore, see, actually, irrespective has only two R's, but I am stressing it now. See, I will tell irrespective of. Somebody from, if they are United States or England, they may tell this person does not know English. Remember, I will tell them, I know this is to stress it, irrespective of. See, sometimes you tell little. See, when somebody is serving something, you don't want too much. Some sweet, what you will tell? Little. Why? Little like that. Little. To stress it. In Kannada, Salpa, or Hindi, Todasa. Why Todasa like that? To stress it. Or see, sometimes slowly come. So, irrespective of load transferred to beam, load transferred only, irrespective of load transferred from slab to beam is UDL or UVL. Anything. It can be UDL or UVL. Whatever it is, UDL or UVL, intensity of UDL or UVL, anything on beam or for beam in unit kilonewton per meter equal to slab load intensity in kilonewton per meter square. See, make a note here. In today's class, this is 9 kN per meter square. I don't want to waste time. See here, 9 kN per meter square, today's class. When you do practical design, you calculate the load and consider. So intensity of slab load multiply by perpendicular distance from beam up to where slab load is transferred to our beam considered. Our beam, which beam you consider? Our beam considered. Or lastly, I will tell in the class. See what I am telling now correctly. Distance can be this way. See, if the distance can be lengthwise, forward or the right side or left side, or that is if the beam is like this. Distance can be this side. That is what? Right side, for you right side. Don't worry about me. Right side or left side. Or if the beam is widthwise, distance can be what? This way or this way. Front side or back side. That distance. Multiply the slab load intensity in kilonewton per meter square. This distance should be in meter. You get intensity of either UDL or UVL for the beam. So kilonewton per meter square into meter up to where? See here now. I will tell once again, you write here. See, once again I dictate. Imagine beam is this way. UDL, UVL later. If the load comes from this side for 3 meter, for our question, see, slab load is 9. If the distance up to where load comes is 3 meter, 9 into 3, 27 kilonewton per meter. Or if it is 3 meter this side, 9 into 3. Or if the beam is this way, if the load comes from front side, say 3 meter, slab load is 9 kN per meter square into 3. Or if the load is backside, from backside slab, 9 into 3. So 9 kN per meter square, 3 is in meter, kN per meter square into meter, 9 into 3 will become 27 kilonewton per meter. That 27 kilonewton per meter can be either UDL, either intensity of UDL, or it can be intensity of UVL, depending upon how the load will come. That I will explain one by one now. Okay, now onwards up to end of the class here. Therefore, now onwards up to end of the class, when I want load transfer to beam and I want intensity of load for the beam, it can be UDL or UVL, whatever is the slab load in kilonewton per meter square, that is 9, I will multiply by up to what distance load from slab is transferred to our beam. That's all. Once you get this answer right here, then for the beam, you add dead load of the beam. That is already told how much. That is weight of wall plus self weight together. See, 13 kN per meter. 13, how 13? 2.5 self weight, 10.5 weight of wall. This 13 kN per meter is always UDL. Remember, this is always UDL. That load transferred from slab can be UDL or UVL. Make a note. See, but Dead load for the beam is always UDL over. Now I will not tell anything. If somebody has no patience to go through everything I tell and not getting clear means pay the penalty. That's all. I will start one by one example now and start. See, I even proved also why you have to multiply by distance. Okay. Now come to examples. Example 1, beam AC. Imagine, see, this is the plan. This is the plan. See, plan means like this. When see, the beam is this way. When you want to see the loading on the beam, you should go to side view. See, side view, you can see beam with the loading and reaction. Same way, here see, the beam is this way. Slab is this way. This is plan, this is plan. These two are, see, beam is this way now. When you want to see the loading on the beam, you should go for front view. Remember, it is front view. So now onwards, when I put the final loading for the beam, if the beam is this way, it is front view. See, loading, reaction. If the beam is this way, it is side view. Remember, okay, now. So next, see, now onwards, I will not tell here. If I put a sketch showing the slab, it is always plan. If I show the loading on the beam, it is either side view or front view, depending on how is the beam. If beam is this way, side view, either this side or this side. If beam is this way, front view or back side view, front view. Okay, now, example 1. See, in the title, I have shown all the sketches. Same I am taking. Imagine beam is 4 meter. See, this is overhang of 2.4 meter. See, this arrow mark shows overhang. Remember, if it is overhang, make a note. Entire load will come to the beam. See, there is no beam here. See, if the beams are there on either side, slab load is shared. Some load will come this side, some load goes this side. If the beam is only on one side, whatever load you apply will come to the beam. See, for a cantilever, entire load is transferred to support. Simply supported beam or fixed beam or continuous beam, loads are transferred to either support. Okay, start. Now, see, I won't explain every time now. This is the plan. This means, see, load on this area of slab will be transferred to beam. Every class, every example, I won't write. So when I put this way, means load on this area is transferred to beam. Now onward, see, I am not writing here. You should write. Load on this area is transferred to beam. See here now. So for the beam from the slab, load will come for what length? See here, 2.4 full length. So slab load is 9. I told multiply the slab load with up to what distance from perpendicular to beam the slab load is coming. It is coming for 2.4 meter. 9 into 2.4 is 21.6 kN per meter is the load transferred to beam. This is load transferred from slab to beam. Not over, right here. Still, this is the load transferred to beam from the slab. Now, final loading on the beam. Load transferred from slab plus dead load of beam. See, you can see here, it is UDL, why uniform, rectangle is there. So, 21.6 is from slab. See, this is from slab. This is dead load of beam. So, 21.6 plus 13 is 34.6 kilonewton per meter of the beam. There will be support will be there, reaction, and remember since the beams are resting on columns, there will be end moments. This end moment you are not bothered today, that come from frame analysis. But I am showing because someone will tell, he is showing a beam later, not now, supported by a column. He is not showing end moment. I am this much structural analysis class I am taking. Do you think I am not knowing? When a beam is rigidly connected to a column, there will be end moment there. That much common sense is not there for me. So I won't. Our purpose is load transfer to beam. See, final answer 34.6. Okay, now example 2. See, this is slab, beam is widthwise, slab is lengthwise. Here, beam is lengthwise, slab is widthwise. Once again, overhang. Full load will come. How much? 9 into, see, perpendicular, see, for the, don't multiply by 3. See, don't multiply by 3 now. Whatever slab load into, for the beam, how much perpendicular to beam? That is, how much? 2.1. 9 into 2.1, 18 point. Same statement here, see, load transfer to, from slab to beam. Finally, for the beam, see, 18.9 from slab, see here, you write here. Next time I won't write. Okay, you write if you want. 18.9 from slab, 13 is dead load of beam. Together, 31.9 kN per meter. There will be end moments here that you are not bothered. In the software or in the practical design, we will consider it. Our purpose is only load transfer. So example 1, example 2 over. Now important examples. One way, see, we are all doing what? See, example 1, one-way slab. Example 2 also one-way slab. One-way slab. Okay, over. Now I will go to further examples. Now, example 3 and 4. Example 1 and 2 were one-way slabs but overhanging side. Now, again one-way slab. See, example 4 also is one-way slab. I will tell you why one-way slab. But too much of RCC I cannot tell. See, example 3 is, see, beam AC, beam AD. This is the column. For your class, columns are not required. But for the software class, columns are required. In the software class, I told them how to place this column. That all I told them how to place that column correctly to flush with the beam. But your class, column you don't see. Okay, now let it be 5 meter randomly. Let it be 3.6. See, there is no beam here, no beam here. That is 2 parallel beams here, supported by columns. No beam, no beam. So, see here, make a note. This slab can bend only lengthwise. See, between the support, it can bend like this. It cannot bend like this. No support here. Therefore, this is a one-way slab supported by AC and BD. So, this is 3.6 meter. Now, see, therefore, see, half the load this side, half the load this side. See, right here. Load on this area to beam AC. Load on this area to beam BD. Next time I won't tell, I will dictate. Okay, start. Again, see rectangle. So, see now, see side view. When you see side view, both the beams are identical. Length is 5 meters. See here. Length is 5 meters. Center up to center of the column. Don't bother about other things all. These are all up to center. Okay, now, see, 9 kN per meter square is the slab load. Load for each beam will come perpendicular to beam for a length of, this is 3.6. 3.6 by 2, 1.8 meter. So 9 into 1.8, 16.2 kN per meter. Load transfer to beam from slab, right? Not over. Now, finally for the beam, 16.2 transferred from slab plus beam has got dead load of 13, together 29.2 for both the beams is the final design load. See, end moment will be there, you don't bother about it. Okay, this is the beam. Simple example, Example 4. Last time it was 2 beam like this. Now, 2 beam like this. Slab can bend only like this now, see. It cannot bend this way now. It can bend only, see, now, sorry. Last time, 2 beams like this. Slab can bend only like this. Now, 2 beams like this. Slab can bend only widthwise. So once again, it's a one-way slab. See, this type of arrow mark shows supported on both sides. I told you, if you put this way, it means overhanging case. Okay, no beam here, no beam here. Again, see right here. Load on, see, once again ABCD. ABCD. You write here. Load on this area to beam AB. Load on this area to beam CD. You should write everything what I wrote. See, this much load for this beam, this much load for this beam. So this is 4.2 meter, half is 2.1 meter. So for the beam AB and CD, from slab transferred is 9 kN per meter square into 2.1 is 18.9 kN per meter. Not over. Finally, see, 18.9 from slab plus its own beam has got extra load of 13, together 31.9 kN per meter. So these are the 2 examples where slab is one way because other way no bending possible. Now come to next case, example 5 and see. See, example 5 onwards, what I will do is, see this example, 1 minute now, this example 3, because the reason I have taken a screenshot for them, so I should stop it. Now, example 5 and example 6. Example 5 only at a time. See, now little bigger one. See, make a note. One-way slab, why you understand little later. You make a note. Consider a slab supported by beams on all the 4 sides. Longer side is 8 meter lengthwise. Shorter side is 3.2 meter widthwise in this case. Next question, I am turning here. Okay. Now, put this sketch. First, those who are serious, actually, this is not my problem. I should tell this is one-way slab spanning in the shorter direction. But little information I want to give. For those who are in the STAAD EATABS batch and STAAD Pro they are coming, this is told hundreds of times for them. And those who came to my RCC class, it is told endless number of times. Still, see, make a note. What all I dictate, you write here. This is a case of slab supported on all the 4 sides. Therefore, there is provision for two-way bending. See, this slab can bend lengthwise supported by AC and BD and also widthwise supported by AB and CD. But will it bend two-way? So two-way bending is, see, there is provision for two-way bending. But IS code told when a slab is supported all the 4 sides, see, if one side is too high, other is small, the predominant bending will always take place, see, in the shorter direction, see, this way. It can't bend this way. But of course, slight bending is there here. For that, we are providing distribution steel. That is over sufficient. So, as per IS code, you find the ratio of longer side to shorter side. See, longer side is called LY, always LY. Shorter side, LX. shorter side is Lx. Find the ratio of Ly to Lx. Ly is 8. Lx is 3.2. Find the ratio. L3 8 by 3.2. 8 by 3.2 is 2.5. It is 2.5. Now, IS code mentioned if the ratio is more than 2, see 2 is from IS code. If the ratio is more than 2, that means the bending along longer is very, very negligible. Predominantly, it will bend in the shorter span. So whenever the ratio is more than 2, you write the slab is designed as a one-way slab. See, one-way slab spanning in shorter direction. This is told thousands of times in the RCC class. For those who are in my class, they will understand very easily. Others, this much I told, sufficient. So, see, it won't, bending in the longer is not required. It will bend only like this. It will bend, see, only like this. Therefore, see, AB and CD are the two beams which are supporting. AB and CD are the two beams which are supporting. AC and BD are not supporting the slab. Therefore, no load for this beam, no load, see, no load for this beam from slab, no load for this beam from slab. Load on, see, correctly divide here. This load goes here, this load goes here. Therefore, see, this is 3.2, half is 1.6, 1.6. On this basis, see, now one-way slab, see here, AB is like this here, CD is like this. 9 kN per meter square into perpendicular beam is 1.6. 14.4 kilonewton per meter. Same thing, 14.4 kN per meter. Load transferred from slab to the beam AB and CD. Note, no load for AC and BD. Now, finally, right here, consider all the four beams. AB will get load from slab. BCD also will get load from slab. AC and BD will not receive, actually it is wrong, see, a small load is transferred there. That we are accounting in the software class. Technically, now as per IS code I am telling, so this beam AC and CD, they are not considered as support for slab. So even then, for those two beams, self-weight and weight of wall is there. So finally, for AB beam, 14.4 plus 13, 27.4, same for this beam. And for these two beams, only 13 kN per meter, as usual, remember, end moments will be there. I won't show the end moment because it's a frame. Length I have shown. This is the final answer for this question, example 5. Example 6, I will not explain much. This is turned this way. Here see, lengthwise longer, widthwise shorter. Example 3, sorry, example 6 will be, I'll tell here now. See, lengthwise longer, sorry, widthwise longer, lengthwise this way. See, here, same theory, it is one way like this. Load will come for this beam and this beam, no load here. So I don't have to explain more. I will write everything and briefly explain. Okay. Example 6, I won't explain much. Again, write slab on all the 4 sides supported. Shorter is 3.9, longer 10. Now see, now also take the ratio of Ly by Lx. Ly is 10, Lx is 3.9. 10 divided by 3.9, calculate the ratio. 10 divided by 3.9. 2.56. 2.56, it is more than 2. Right here, IS code 2. Since the ratio is more than 2, the slab is designed as a one-way slab spanning in the shorter direction, see, like this. So therefore AB and CD beams are not supporting the slab, but actually slight load will come in the software class. I will explain that one. I will see that some load will come on AB. Practically little load will come there. That now we are going for theoretical or as per IS code. Okay, now start. Now remember, no load for this beam from slab, no load for this beam from slab. See, now divide like this. See here, 3.9 by 2 is 1.95. This load right here, load on this slab, this area of the slab to the beam AC, all I told last time. If you are lazy and do not write, you are losing. And load on this area is for the beam BD. So for these two beams, 9 into 1.95, 17.55 and 17.55 right here. This is load transferred to beams from the slab. And finally, considering the self-weight of the beam and wall load, these two beams from slab 17.55 plus dead load of beam 13, 30.55 for these two beams, and only 13 kN per meter for this beam. How much I explain? Beyond this, if you want to explain, you better study somewhere else. Now, sorry, I should see, important is I should stop, because for the software class people, they should take screenshot. Okay, example 6 over. I will restart. Now, lastly, two-way slab. Example 7 and 8 are pending, but before I go there, I want to discuss something. See, right here, 2 cases. What all I dictate, you have to write, if you are interested. Consider, see, later, this will be example 7, this will be example 8. Okay. Consider a slab supported on all 4 sides. Let the longer side be Ly, shorter is Lx. Here see, lengthwise Ly, widthwise Lx. Widthwise Ly, lengthwise Lx. Don't by heart that way. Let Ly be the longer side, Lx be shorter side. Since the slab is supported on all the, see, this arrow mark later. Since you do one thing, first you write this much only. You first write only these 2 sketches, you write first. Good for health. Since the slab is supported on all the 4 sides, there is provision for two-way bending. So it can bend this way, supported by AB and CD, bend this way, supported by AC and BD. Same thing here also. Now, whether it is designed as a one-way, two-way slab or one-way slab depends on the ratio Ly by Lx. See, if the Ly by Lx is more than 2, one side is too long. When one side is too long, see, it will bend in the shorter direction. But when one side is not too long, see here, it will bend both ways. So this all comes in RCC. I told it hundreds of times in RCC class. So if Ly by Lx is less than 2, it is designed as a two-way slab, but note, even if it is a two-way slab, predominant bending is in the shorter direction. So this is two-way slab. See, bending like this and also bending like this. But remember, this is predominant bending. See, predominant bending here. It will bend like this and also bend like this. Predominant bending in the shorter direction. Okay. Now write. Now, in this case, IS code told, see, draw 45 degree from the shorter side. See, now, this is Lx. See here correctly. This is Lx. When this is 45 degrees, this will be Lx by 2, Lx by 2. High school level mathematics. See, if this is Lx at 45 degrees, Lx by 2, Lx by 2. Now, since it is 45 degrees, if it is Lx by 2, Lx by 2, this also is Lx by 2 only, not Ly. Lx by 2, but the middle portion will be Ly, total is Ly minus Lx by 2, minus Lx by 2 is Ly minus Lx. See here, Lx by 2, Lx by 2, Lx by 2, Lx by 2, Ly minus Lx. Now, see, right here. See, not this way. Load on this area transfer to AB. You should write everything if you are interested. Load on this area transfer to AC. Load on this area transfer to CD. Load on this area transfer to BD. Here, load on this area transfer to AB. On this area transfer to CD. This area transfer to AC. This area transfer to BD. Therefore, if I take this case, see here, for the beam AC and BD, see, AC and BD, 0 at the ends and maximum at center. Let it be W. Let W be maxi. W is maximum intensity. Maximum intensity for all four beams. All four beams. Okay. Here, see. Now, so 0 to maximum. 0 to maximum. See here. But here not that way. 0 to maximum. 0 to maximum. Central portion constant. See here. 0 to maximum. 0 to maximum. Lx length. See. This is Lx by 2. Oh, sorry. Lx by 2. This also Lx by 2. Misprinted. Lx by 2. Then here I wrote correctly, I think. Here, see, I forgot. Divide by 2. I don't know why I forgot it. Lx by 2. Okay. So, make a note here. For the two shorter beams which are supporting the longer span, lesser load. 0 at the ends. See here. See, here these are shorter beams. Here these are shorter beams. 0 at the ends and maximum at center. Length is Lx by 2. For the two longer beams, see, which are supporting the shorter span, see, 0 at the ends reaches maximum at Lx by 2 from ends, then central length of Ly minus Lx, see, central length of Ly minus Lx constant here. Central length of Ly minus Lx constant. Now, see, right here, irrespective of, right here, of whether you want intensity W for shorter beam or longer beams, principle is, it is W for slab. Our example, this is for our class example, remember 9, if you remember, 9 kilonewton per meter square per today into for what length perpendicular to beam load is transferred. See here, for this beam for Lx by 2, for this beam for Lx by 2, for this beam also Lx by 2, Lx by 2, not Ly by 2. So W for maximum intensity for all the 4 beams will be W for slab into always Lx by 2, Lx by 2, Lx by 2, Lx by 2, right there. When you calculate intensity, Ly will not come. But Ly will come only once, where when you mark the central distance for the longer beams where intensity is constant. Since it is Lx by 2, Lx by 2, total Ly, see, total Ly minus Lx by 2 minus Lx by 2 is Ly minus Lx. So lastly I will tell now, without seeing there, whether it is this way shorter or this way shorter. Mark the triangles and trapezium. 45-degree angle, start from the shorter, come by Lx by 2, extend further, again mark one more triangle. Intensity of load for the beam, for any beam, maximum intensity is W for slab into Lx by 2. Whether it is longer beam or shorter beam, maximum intensity for all the 4 beam is based on Lx by 2 only. Okay, then shorter beams, 0 at the ends, maximum at center. See here, 0 ends, maximum center. Longer beams, see here also, longer beams, 0 at the ends, reaches maximum at Lx by 2, and then central length of Ly minus Lx, it is constant. This much is over sufficient. Now I will go for, see, I removed everything now. I will go to last 2 examples. I want full board, so I removed it. Remember, slab load is 9, beam load is 13. Okay, I will start now. Last 2 beams, last 2 slabs. Consider example 7. See, 1 minute. No, I think I pulled the camera. Maybe. No, okay, no problem. Actually, when I moved, the cable got pulled, tension. So I thought the camera might have shifted. No, nothing to worry. Okay, now see. Consider a slab supported on all the 4 sides. Longer side 6.2, shorter side 4.8. Take the ratio. So there is provision for two-way bending. Ly by Lx is 1.292 less than 2, two-way slab. Now right here. See, even if it is two-way slab, predominant bending is along the shorter span. Okay. Now, see, shorter span is here. See, your Lx is the most important. See, Lx equal to 4.8 meter. So Lx by 2 is the most important, 2.4 meter. Now see here. Load on this area to AB, load on this area to BD, load on this area to CD, load on this area to AB. These all you have to write if you are serious. Not write AB, you write here. Now, see AB. 0, 0, maximum this distance required. See here. This distance is, I told you, see, if this is, see, first what you do is, you write any one side, okay, I'll put somewhere here. Oh, wait, right now. This load is on AB, okay. This is load on AB, see here. This is, Lx is 4.8, so half the length is 2.4 meter. You write here, Lx, you write Lx by 2, actually I wrote there, Lx by 2 equal 2.4. Then this also is 2.4 meter. This also is 2.4 meter. The central length is total, one place sufficient. See, total 6.2, subtract 4.8, it is 1.4 meter. Show the calculation. I have shown the calculation there once again. Okay, now see, for this beam, load comes for 2.4 meter. For this beam also 2.4. I told already, whether it is shorter beam or longer beam, see, 0, 0 maximum, 0, 0 maximum, 0 maximum constant, again 0, this way. So this ordinate, this one, both are same, equal to, I just now told 10 times, intensity of slab load is 9 multiplied by Lx by 2, 21.6, 21.6. This is right here, load transferred to beams from slab. From slab. Okay, now little more is there. 1 minute now. I will tell little more. Where is that rubbing one? I put it somewhere here. I want it now. I don't know where I kept it. Okay. Here. Okay. Now this I will remove. Okay. 1 minute now. Okay. No problem. I will remove this one now and go for something else now. Some important concept. See, correctly understand everything. Therefore, finally, for beams, you write here, considering load transferred from slab plus dead load of the beam. Load transferred is there. Dead load is already known for you, 13 kN per meter. What happens now is, see now, correctly. This beam AB, big sketch I will write now. Now see, sketch is bigger. This is the most important. AB is here. Here. Space this side further. AB is here. This way. This is your CD. Scale is not maintained. Take front view. For these two beams, take side view. See. Take side view. Side view for these two beams. Leave some small gaps there. Some gaps here. See. Now, A, B, C, D, A, C, B, D. Here. First do one thing. Load from slab you write later. See, first there is dead load for the beam, which is UDL, everywhere UDL. Important. Here this way. See, lengthwise beam front view. Here, oh, I should do from this side. Why? From this side I am looking. Okay. This way. How much it is? 1 minute. It is somewhere here, right? 13 kN per meter. This also 13 kN per meter. Somewhere here. 13 kN per meter. This is there for all the beams. 13 kN per meter. Plus for this beam, see, this way, extra from slab. How much it is? 21.6 kilonewton per meter. This also 21.6 kilonewton per meter. See here for this beam also. See here. Same way, scale is not maintained. See, feeling tired now. It is early morning now. Okay. This also 21.6 kilonewton per meter. 21.6 kilonewton per meter. Here also, see, from slab 21.6 kilonewton per meter. Here also, see, extra load of little neatness is gone now because feeling tired. This also 21.6 kilonewton per meter. Okay. Now, one important. Let me check the camera once. Is everything is okay? Okay, everything is okay. Now, concluding part is this, see, When you go to loading diagram, finally what will happen is, in the software class, I will explain everything. But here, see, this I will remove. Correct answer? 2.4, 2.4, all correct now. Distance I will mark later. Okay. Therefore, see now. Finally, see, this is the final answer. What you can do is, this is equal to, see here, equal to beam. This to understand correctly. For SFD, BMD all, it will come like this, see. It will come like this. This way, here, some space here. Some space. Don't worry about distances all. I'll put distances correctly. Some space, small space. See here. Now, reaction, 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 reaction. Load is from this side. Reaction, 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 reaction. Okay, distance I'll put later. Okay, now A, B, C, D. A, B, B, A, C, C, D. Moment will be there, end moments. Correct. You never bother about end moments all. Okay, then, see here. You add these two. See here, 13 kilonewton per meter here. To understand correctly, how is the final answer? See, here it is 13. 13 kilonewton per meter. Here also C is disturbing me. Okay, C, okay. Here also 13 kilonewton per meter. See, here also 13 kilonewton per meter. Here also 13 kilonewton per meter. Even here also 13 kilonewton per meter. Okay, space. Oh, here space problem is there. I should shift the beam further this side. It is overlapping. Okay, okay. A beam, you go that side. A B, okay. A beam, you go that side. You are disturbing me. Okay. Disturbing me. Okay. This is B, this is D. And moments are there. Reactions are there. See, 13 kilonewton per meter. Here also 13 kilonewton per meter. When you come here, 13 plus 21.6, it will come like this. See, it will come like this. Is 21.6 correct? I am getting doubt about that value. 9 into 2.4. 9 into 2.4 is 9 into 2.4 is 9 into 2.4. Okay, correct, 21.6. This will be, see, B is here. This will be 21.6 plus 13 is 34.6 kilonewton per meter. This is the final answer. You write here how I got 13 plus 21.6 is 34.6 kilonewton per meter. Distance is from here to here and here to here is 2.4 meter and 2.4 meter. This beam length is 4.8 meter. I will write here 4.8 meter here. See here. This way it will come. 13 is there. 13K, no space to write here. 13 2. See here. This is same. How much? 34.6 kilonewton per meter here. Here also 34.6 kilonewton per meter. This beam length is 6.2 meter. These two beams, these are 4.8. This is the final loading diagram for the beam. See, 13 per 21.6. See here. Oh, sorry. Something wrong. See, okay. See, I will tell you one thing. It is now approaching early morning. See, I forgot this only. Okay, no problem. What is there? Sometimes it happens. See. Okay. Now correct. What to do? See, feeling too tired, it happens. So this is 34.6 kilonewton per meter. This also 34.6 kilonewton per meter. Same here. Remove it. 34.6 kilonewton per meter. Here also 34.6 kilonewton per meter. This distance is 2.4 meter. This distance is 2.4 meter. Same here also. Central length is total 6.2 minus 4.8 is 1.4 meter. This is the final, see, little odd actually. Oh, see the problem. Okay, now correct. This is 13 kN per meter. See, if you do non-stop class this way up to early morning, this is what happens. 13 kN per meter. These are all called oversight. Okay, this is the final answer. Luckily, I observed it here. Otherwise, tomorrow someone will comment, this person does not know how to add the loading. Okay, correct. 34.6 is correct. 21.6 plus 13 is 34.6, 2.4, 6.2, everything is okay. Now, lastly, example 8. Okay, I write it. This question, I will not explain much now. See, okay, I've got some arrow marks here. Okay. Right, example 8, last example. A slab of longer side 7.4, shorter 5.1. This time, longer is widthwise, shorter is lengthwise. Right here, Ly by Lx. See, again, all round support is there, so two-way bending is possible. It is 7.4 by 5.1. You calculate. Okay, I will calculate what is there. 7.4 by 5.1 is 1.451. 1.451 less than 2. Right here, therefore, two-way slab. Two-way slab, predominant bending along shorter. See. Now write one more sketch here. Show predominant bending. Also bending is here. Okay. Now mark here. See, Lx by 2, Lx by 2, Lx by 2, Lx by 2. Center is Ly minus Lx. Everything written here. Load on this portion for AB beam. Load here for AD. Load here for CD. Load here for, see, you can make a note here, CD. This load, see. Load here for AC beam. You write clearly everything. For AC beam. Okay, start now. Fast I will tell. See, shorter beams, AB and CD. This distance is Lx by 2, Lx by 2 is 2.55 meter. 2.55 meter, 2.55 meter. And this beam, this is Lx by 2. 2.55 meter. This also 2.55 meter. This is Ly minus Lx is, how much it is? 2.3 meter. 7.4 minus 5.1. This is load transfer to beam from slab. Right here. Still not over. Okay, now last step. Over. Everything is over. See, I will remove everything now. See, first of all, this much explanation is not required now. See. Now, lastly, right. Therefore, finally for beams, right here. Finally for beams, considering load from slab and also dead load of beam, the loading for the beam will be, see, this beam, I write here, little this side. The space problem is there. Okay. Here. Little more space I will give this time. This beam and this beam. Longer beams. These are the two shorter beams. Some space give there. Some space. Little further space. Okay. As usual, A, B, C, D. Okay. See here now. First, do one thing. Mark the UDL. All the beam has got dead load. Mark it here. Oh, sorry. You are seeing from that side, so here. Okay. How much it is? This is 13 kN per meter. Right, everywhere. This is 13 kN per meter. Same. What is there? Same thing here. 13 kN per meter. This also is 13 kN per meter. Then for this beam, see, this way. How much? 22.95 kN per meter. Here also. This is from slab. Too much neatness I am not going now because feeling very much tired. See, 22.95 kN per meter here. See. $22.95 kN per meter. Here also, ink is also gone. 95 kN per meter. This distance all I write later, not now. Next sketch I will put distances. See. Okay, little sketch. 22.95. See, as I feel tired and more, writing also is not very neat. Okay, no problem. Okay, now, last answer. Little ink I have to put for the pen, otherwise last presentation will not be shiny. Okay. Okay. Now, everything is over. I will put the last answer here. Everything is correct? 22.95? Okay, everything correct. The last final answer for the beam is, see now, final or this will be, see, this is equal to, see, neatly, one beam here. Little more neatly I will write, one beam here. One more beam here. Lot of space I want now. Neatly, this beam. One beam here. So that no space problem. One more beam here. Okay, here. Now, see, every beam has got reaction. I forgot to enter reaction last time, I think most probably. No problem. You enter here. Reaction. And also there will be end moments. That you are not bothered. But I am bothered because why? Without that, my structural feeling will not be there. See, this length is 5.1 meter. This total length I mark here for everything is 7.4 meter. Then, see here. 13 here. See, 13 here, 13 here. Then here, 22.95 plus 13. Here we calculate. 22.95, correct? Yes. Plus 13 is 35.95. Here. This way. This is 13 kN per meter. This also 13 kN per meter. This is, I forgot now, 35.95. 35.95 kN per meter. How I got it? This is 13 plus 22.95. That's how I got this one. See, this is the final loading for the beams. This distance, both are 5.1 by 2, 2.55 meter. This also 2.55 meter. 2.55 meter. Full length you can see here 5.1 meter. Same answer here also. 13 13 to same answer here. 13 kN per meter. Here also 13 kN per meter. Here 35.95 kN per meter. This beam, I think I will shift a little more. Space problem is there. Okay, shift it here. Here, okay. A beam, go that side. Here you have space problem. This is A, B, A, C, C, D, D, B. As usual, end moments are there. Reactions are there. Okay. See here, this beam. See, any one place you write here. See here. 13, here 13. See, A is, put A that side. C also come this side. See here 13. 13 kN per meter. Here also 13. 13 kN per meter. And then, after coming by a distance of 2.55 meter, and here also move by a distance of 2.55 meter, at that time it will be how much? 39.30. See, 22.95 plus 13 is 35.95, somewhere here. Okay, here and here. Okay, see. Okay, done. It is too much. Okay. Okay, here, see. Okay, somewhat neatly I have drawn. Furthermore, neat is not possible. This is 35.95 kN per meter. This also 35.95 kN per meter. Now this central length is 2 point, how much it is? Forgot. 7.4 minus 5.1 is 7.4 minus 5.1 is 2.3 meter. Total length is there, 7.4. Here also, see, AB, you are disturbing me. Okay. See here, 13 kN per meter. Here also, 13 kN per meter. Here, see, more than this neatness I cannot draw. Feeling too much tired now. It is actually early morning now. I started recording at around 12 o'clock. See, it took nearly 4-5 hours because duration of the class may be only 2 hours more, but writing is there. This is 35.95. In spite of all this, if any mistake is there, I won't correct it now. I will put in the description. Okay. 35.95, 35.95, 2.55, 2.5, 2.3, total 7.4. Everything is over. Okay. Done. Now, see, little turned here. Do not bother about all these things. Now, those who are in the software class EATABS&SAFE and also in the upcoming class STAAD Pro, thoroughly go through. Others, utilize this opportunity to learn. Okay, thank you. We will meet again next time when I upload some class from software. Some important class I may upload. But regular engineering mechanics will come. Tomorrow it will come once again. Okay, thank you.